Good morning, everyone. Welcome back to the third morning of EAMS. We've just had a slight technical problem, so I'm sorry about the 2-minute delay in starting this morning. This morning we've got two talks about JSX Graph. So this allows us to include more interactive components in our web pages and our online assessments. So as before, I will just remind you. Where are we? Here we go. Let me share my screen. We have got the questions should be put into the questions chat. So let me copy that and just post that into, I will post that into the chat in a minute. But if we could put questions here, you'll see from the previous talks on previous days that the questions are recorded here. I haven't had time to catch up on all these, of course, but the conversations are recorded. Speakers can record their answers after the session, and none of this gets lost in the Zoom chat. So let's go back. Our first speaker this morning is Alfred Wassermann from Bayreuth University in Germany, who's going to talk us about the items project, JSX Graph and formulas in Moodle. Alfred, are you ready to begin?
Can you hear me?
Yes.
Okay.
Over to you, Alfred.
So welcome everybody. It's a pleasure for me to that we are allowed to present our project, our European project items today. And specifically, we want to show you recent work on using JSX Graph and the Formulas Moodle plugin for a high school math course in Spain. We are Igor Pesek from University of Maribor in Slovenia, and Marc Bernat Martinez from the startup company Bon Nuedo in Spain, which focuses on teacher development and IT support for schools. And I'm Alfred Wassermann from University of Bayreuth, and I'm the lead developer of JSX Graph. So what do we want to show you today? First, I want to give you a glimpse about our library JSX Graph. Then I want to show you the JSX Graph filter. And then we go into details about the items project. And in the items project, we focus on producing content for Moodle, or in Moodle, for using JSX Graph and Stack, as well as JSX Graph and formulas. JSX Graph and Stack will be presented in the next talk, and I hope you will see, or I'm sure you will see very nice examples there. And finally, I will show you the JSX Graph book, which will be which is in development, and invite you to the JSX Graph conference. And at last, Marc Bernat will go with you through the course and show you some examples. So, yeah, okay. JSX Graph is an open source project since 12 years meanwhile. It's focusing on interactive geometry, plotting, visualization, mathematics, and it's a pure JavaScript library. If you download it, if you use it in your browser, it takes you 160 kilobytes. And it's, so like you see in this code example, you can create mathematical objects like points, spline curves, gliders, tangents with JavaScript in a division. Now do you see still my screen? Do you see the JSXgraph homepage now?
Not yet, no.
Okay. So this is the homepage of JSXgraph, and there are a lot of examples.
Sorry, Alfred, we can't see your screen at the moment.
Oh, okay. Now?
No.
So I'm struggling with my Mac. So do you see now this? No. Okay, then I will stick with the presentation.
Is there something that I could share, Alfred?
Okay. Do you see the presentation now?
No.
Or did I lose everything? So, well, I just continue probably. So JSXgraph is also able to do function plotting, and for this we have implemented a parser, so you can input just the usual math syntax like sine of x times x or x to the square, and everything will work out. Okay, and then we have developed a Moodle filter, which is now officially in the Moodle plugin directory available. This allows you to include every JSXgraph construction with this JSXgraph tag, which you see on the bottom. There you supply the dimensions of the rectangle, and then you can include the code. Okay, in practice, this looks like this. You open a resource like a page or a label, and then you write down the text. And it's good to use the HTML view of the text, and then you can input here the JSXgraph. I hope you can see it, the JSXgraph tag, and followed by the code. And this would result in such a construction.
Alfred, we'll just pause for a second. Mark has offered to share his screen, so we should be able to follow along. There we go.
Okay.
Thanks, Mark.
Okay. The ITEMS project is a European project, an Erasmus Plus project running from 2018 until 2021. And the objectives are to create STEM-based modules, integrating e-assessment tools, to research on the use of JSXgraph, to measure the effectiveness of the content, and to promote professional development and distribute materials as open educational resources. And we're using MOOCs to present materials. And there, in this project, we have a Moodle installation. You see the URL, the Moodle items pro EU. Everybody has access to it through a Google account, if you accept a Google account. If not, you can just send an email and we give you a private account. And from there, we share the content. It's possible to share the content with LTI For example, for this EAMS conference, the course is shared with LTI. And the content is, well, a lot of prototyping work using JSX-Graph, and we are developing courses for physics, mathematics, and science for high school, and we have also partners, especially from Finland, Matti and Pekka, for higher education. Okay. So, in this talk, we want to present you using JSX-Graph with a Moodle formulas plugin. I don't know if everybody knows the formulas plugin. It's, so to say, the Pullman's version of, I don't know if I embarrass anybody here, but it's an easy introduction into randomizing questions. It has less, there's less to install on server side than Stack. And yeah, okay. And the main thing is you can randomize the question and save the user interaction. For example, you see on the right-hand side, you see a typical question from our Moodle, sketch this function graph, and these points are initially at they are all 0, and you have to put it in the right position. So, but now I'm a little bit, I would need so we don't I just don't know how I should solve this quickly. Maybe like this. So, do you see now the GitHub? What do you see now?
So Mark is still sharing his screen, Alfred.
I think what we'll do is, if you could just tell Mark what you want to show, we can all see Mark's screen.
I want to show the Moodle formulas JSX-Graph site at GitHub. Okay. Ah, yeah. Okay. So usually this Moodle formulas plugin works with text input fields. Okay, and so the student has to type the solutions, which may be various numbers, into this input fields. And now we have the task that we have to combine it with this JSX-Graph construction. Maybe you scroll a little bit down, Mark. Yeah, a little bit more. More. Okay. And Moodle formulas works like this. You define some random variables. Here you have A and B. A is allowed to take the values 2 and 3, and B is allowed to take 10 and 20. And now you define some solution variables, y1, y2, y3, y4. and depending on these, maybe depending on these random variables. And then if you go down a little bit more, the answer is, the correct answer would be y1, y2, y3, and y4. And this is usually has to be input into input type text fields. And the solution now using JSXGraph is, we have this small library of this small JavaScript file JSXQuestion, which you see in line 4 of this code example on the bottom. This has to be included. And then, if you please scroll down a little bit, you see this formulas get all values. This is the getter method to read all values from formulas, if there are any. Otherwise, they receive the default value 0. Then everything else is it's JavaScript, or it's JSXGraph. And down below, we add an event listener, and whenever something happens on this construction board, we send it to formulas with this set all values. And and this enables the communication between JSXGraph and formulas. Mark, Bernard, could you show an example? Could you show this example live? Is it a big problem for you? Yes. Yes. So it's obviously it's 23. Yeah, not quite, but close. Yeah, okay, let's say we are not that perfect yet. Okay, it's not quite perfect, quite correct, but close. So, and now, yeah, this the assessment, so to say, was done by the checking was done by formulas. Okay, thank you. Okay, this is a more advanced example, also using formulas with many fields. Maybe we can go back to the presentation. Yeah, one slide back, please. Yeah, at the moment we're working on a JSXGraph book to learn JSXGraph programming. It's an open source project at GitHub. You see the link on the presentation, and it's also in this demonstration course, which is linked on the EAMS site. While it's under active development, we translated in quite a few languages, which you see on the screen, and though it's very easy to add more languages if you are interested. Okay, and then I want to invite you to our online JSXGraph conference, the first JSXGraph conference. We are very proud. It will happen on October 6th to October 8th. And it will, topics are examples of JSXGraph for learning, teaching, using JSXGraph in Moodle, Ilias, together with Stack, best practices, tools, new developments. So everybody is invited to submit a talk or just attend. Attendance is free, but you have to, we want you to register. Okay, then maybe Mark, you can show the course site again.
So while Mark, thank you for your technical support here. While Mark is just moving to the other side, could I encourage colleagues to post questions in the Moodle forum?
Yes.
We certainly have a few minutes for questions. Thank you, Alfred. I'm sorry you've had technical problems. We'll follow up with you later about what we can do about that. So here's the demo site again. Thanks, Mark.
So maybe Mark will continue, and then we will answer questions.
Well, I'd like to kick off with one question, certainly, Alfred. So when I'm designing Stack, what I really want to do is to try and provide useful tools for the teacher that stops them having to become a programmer at every moment. I put a lot of effort into designing the answer tests so that people don't have to worry about how to establish something, but at that moment they can think about algebraic equivalence rather than how to establish algebraic equivalence. And my experience with JSX Graph is you're very much a programmer all the time. You have to program everything. Now, of course, that gives you absolute freedom, which we like, but it duplicates code and makes it very difficult sometimes to get simple things done quickly and efficiently and in consistent ways. So do you have any plans for abstraction layers for common plotting a graph or doing a geometrical diagram where you just specify the minimum information?
Yes, of course we want to provide this basic layer JSX graph so everybody can do everything with it. Our partner from Slovenia, Igor Pešek, his group has developed a very basic user interface to create geometric constructions. So this is one part. Then we are working on a project we call Sketchbin, and for this may I share my screen? I will show you.
Certainly, Alfred, if you're able to, that would be great. Yeah.
Yeah. But you have to, Mark, Bernard, you have to leave your screen, get out.
While you're doing that, I'm just going to post something in the chat, Alfred.
Okay.
At some level, as a question author, I would just like to type that. That strikes me as the minimum information I would need to say, give me some reasonable plot of x squared between -5 and 5. So
we are working on this Sketchbin a little bit.
Okay.
No, it's on all.
Will that be announced? Will that be ready at the JSX Graph conference?
It's already ready. It needs maybe some upgrade. There you can sketch. It's heavily based on our language Jessie code, which is the parser, math parser, and you can sketch your construction on the right-hand side. Just sketch it on the right. Seems broken at the moment. I was not prepared for this. So usually you can sketch on the right-hand side and you see the code on the left-hand side. Well, the high profile interface is sketchometry. This is a tool based on JSX Graph, focused on smartphones and tablets where you work with your finger or pen.
Right, so that seems like a very useful user interface, but a very super simple programmatic interface, almost like a scripting language, which you accept some loss of control for the benefits of efficiency and consistency. there's always that tension, isn't there? I mean, you've provided these great JSX graphs tools, but you know, to get one of the mistakes I've made with Stack, I think, is not to make it easy to get started.
Mhm.
Where's the hello world program, which might plot x squared comma x comma minus 5 comma 5 might be the graphical equivalent of the hello world program. Now Stack is a long way from that, and it's awful to try and get people started. It's a real barrier. So there's some tension, isn't there, in the design when we're creating these systems between making it super simple for people to get started and then still providing all that full flexibility in the background.
So the closest thing we have is Jesse code. There you have you can construct a point, for example, like point 1 and 2. But of course, I'm afraid that many people, if they want to program something, it's getting complicated anyhow. It doesn't depend on the language.
We've got another question in the chat. Can it be used for graph theory?
Yes, it was used for graph theory, and well, the code at the moment is not integrated. Maybe we make this public, these parts, the graph theory parts public again. It's not maintained at the moment, but people use it for graph theory.
Yes, and certainly we've used it for graph theory inside Stack. I hope George might be. Are you going to? George is shaking his head. He's not going to demonstrate that. Well, Alfred, I'm so sorry you've had these technical problems. Thank you very much for your talk. I think JSX Graph is a very exciting tool. We use it. It looks great. It's reliable, and we'll talk to you afterwards about what we can do to make your presentation available. I think this is a good time to switch talks. So thank you, Alfred. George, if we switch over to you now, you're going to talk about JSX Graph more specifically in Stack.
Thank you. Let me just turn on screen share. There we go. Okay, so you've had a bit of an introduction to what JSX Graph can do, so I guess I shouldn't dwell on that, but what I'm going to focus on is how I've been using Stack, Stack with JSX Graph questions embedded within. So I can use JSX Graph to produce nice graphics, and towards the end I'll talk about how I've been also using it to be the task itself, so interacting with the JSX Graph graphic is part of the task for the students. First of all, I'll show you examples of how to integrate JSX Graph into Stack. So that's the sort of hello world example that Chris was looking for. Then I'll go on to talk about the problem of randomization. So often you want to produce lots of random versions of a question, and that means that the graphs are going to end up looking different, and you need to worry about how to produce those different graphs. I think I don't know if it's especially novel, but I've come up with a way that works for me to solve the problem, and maybe it'll be useful for you too. And as I say, towards the end, I'll show you some examples of interactive JSX Graph elements that are used as part of the task. So starting off with how you actually get JSX Graph into a Stack question. And I suppose I should also say this is not necessarily specific to Stack, some of what I'm saying. If you do want to use JSX Graph in other systems, I think some of what I'm about to say will translate. It's just that the exact implementation of it will be slightly different. So JSX Graph, as we've just seen, lets you produce graphics, so things like you might otherwise do in something like GeoGebra, sort of dynamic geometry. It can plot functions and so on as well. And underlying all of that is JavaScript code. So that's the code on the left there for the plot that you see in the middle. And the JSXGraph website has a whole kind of library of examples. So what I often find myself doing is finding an example there that does kind of something that I want to do and copying the code. And I was interested to see the JSXGraph book that was linked to in the previous talk, because I think having more of these examples is only really useful if you're getting into writing JSXGraph. It's great to see lots of other examples that you can work with. So how to use it in Stack? There is a way that you can easily embed JSXGraph code within a Stack question. So this is just taken from the documentation. So the link at the bottom of the slide there takes you to the Stack documentation. And this is the kind of basic example that's given there. So up at the top, we've got our a and our fx. So those are the random variables in the question. So we're defining sin x plus or minus some random number. And then within the question, I insert this JSXGraph block, and in there I can put my JavaScript code. So this is just about the simplest code you could imagine for just plotting a single function. And here's the result that we get. So the student sees the random graph and then is asked to type in the expression that corresponds to it. So that's just about the most basic example you could imagine. One pitfall with this, so notice there's the comment in JavaScript code. This caught me out when I was writing a lot of course content, and some of it included JSXGraph. And when I went to import and export the question bank, this did sometimes cause problems having these comments. What it turned out was that the line breaks were being lost at some point in the import-export process. And so my whole JSXGraph code was being turned into one single line that was all commented out, which was not good. I did some testing earlier, and I think that maybe has now been fixed with the Moodle import-export. But nevertheless, I've tried to get into the habit of avoiding using those single line comments and doing the delimited comments instead. So that's just a tip. If you do make a mistake with your JSXGraph, what I've found is that you essentially just get a blank plot, and I need to use the inspector tools, the developer tools within my browser to kind of really track down what the problem is. So in that respect, it can be a little bit fiddly to maybe sometimes track down exactly where the error has cropped up. Anyway, once you get past that, you can do good things. You heard on Monday, my colleague Richard Gratwick was talking about this course that we developed 2 years ago, Fundamentals of Algebra and Calculus, which is entirely online. And through the EAMS site, you have access to a demo of 1 week of the course materials. So the two graphs that you're seeing there appear in those course materials. That's a week about polynomials. So in the section on graphs of polynomials, naturally there's going to be a lot of graphs coming up, and JSXGraph is used quite heavily there. So as I say, the link to that is available if you log in through the EAMS site. It's used elsewhere in the course, so the demo only covers that week on polynomials, but in the course there's a week on integration as well. So there's this applet, which I'll come back and show you in a bit more detail actually at working. But that uses the interactive feature of JSXGraph. And there's various other kinds of plot that I produce using JSXGraph in the course. So moving on to the kind of first main thing that I wanted to explain, how I go about it, is how to randomize questions. So the idea here is going from one question to many questions. So quite often you'll start with a question that was on a tutorial sheet or some other source, and you think, oh, that's a nice question. I want to take that, use it in my quiz, but I want to create lots of random versions of it. And I used to find this quite annoying to have to do with graphical questions, having to figure out how to do all the transformations. So ultimately, we want to turn that into a question in Stack, but we also want to have lots of different random versions, and the graph should reflect the different random parameters that appear. So the way I ended up solving this was to think about it sort of mathematically. So what we are doing is a transformation of the plane. So we want to take our picture that we've got from our tutorial sheet, apply some transformation to it, and arrive at our new picture. And the transformation that you want to apply really is some sort of scaling and translation. So you want to do a horizontal dilation, a vertical dilation, usually for me by integers, so that if I have that point that's when x is 2, and I think y is -3 or something, I don't want to end up with a point that's at 7/52 and pi or something. I want to have nice integer values. So if I just use scaling by integers, then I will retain that property. And likewise, I'm happy to translate the plot. And of course, if I make the scalings negative, then it will flip things around as well. So you get even more variation that way. So essentially what you're applying is this transformation of the plane. So you choose these 4 random parameters, and you want to apply this transformation. So what you've got to do is transform all the things that are on your picture. So first of all, you want to transform the points that are there. So the A and the B, for example, on the left-hand picture. And that's quite easy to do just using that formula. So we just apply that transformation to the point. Also, it was 2 - 4 on the left-hand picture. This point here becomes 1, 3. And so there we go. But we also want to transform the curves that appear on the plot. And this was a bit of a programming exercise for me in Maxima, which is what's used behind the scenes in Stack. So to transform the expressions, I wrote this little function here. So I guess that's an exercise for you. It's a nice little programming problem to do. So you can ignore that you've seen that answer there, try and solve it for yourself. But essentially you give it in an expression and it gives you back the transformed expression in the new coordinate system. So with that, it's very easy to then create these different random versions of the question. Another sort of wrinkle in all of this is dealing with the bounding boxes. So if I actually just whip back and show you the hello world example. So this one here is just set to use a bounding box that goes in JSXGraph, that goes from the left, the top, the right, and the bottom. So it goes -10, 5, 10, -5. So that's the kind of window that we have here, going from -10 to 10 and -5 to 5. And that's been chosen so that all of the different random versions will appear in this plot. But if you want to take more control of it, and maybe we don't want to be going so high up the axis here, we want to make the viewport match the random version that we're working with. So with this transformation approach, it's quite easy to do that. All we need to do is think about the corners of the original picture and where they get transformed to. So that's how I do this in the Stack code. So the top left corner of the bounding box becomes the transformed point. So this is roughly where -5, 15 is on that picture. And this is roughly where 6 - 35 is. And I just look at where those end up on my transformed coordinates. And that becomes my new bounding box. So what I do is I look at all of the x coordinates of that. So the x coordinates of the 2 new transformed boxes. But I also add in a -1.5 and a 1.5 because I want to make sure that the origin is always in this picture. And I do the same for the y coordinates. And then I just always use this line because I never remember which way around JSXGraph wants to know the bounding box. So I just find myself always copying and pasting this code. So this just says make the bounding box so that it includes all of the coordinates that I've given up here. So it will definitely include all of these x coordinates and all of these y coordinates. And once you've got that, this list that I've defined in the random variables in Stack, that just gets inserted into the JavaScript code. So I found that quite a useful technique. This is maybe something that, as Chris was suggesting, this is a sort of abstraction that I've sort of invented for myself, and I find myself just copying and pasting this between questions. So maybe this is the sort of thing that could be abstracted out a little bit so that you don't have to worry about the details of this. So moving on to the second thing that I wanted to show, this is how I've used the interactive features of JSXGraph in the course. So I think for this I might switch to actually showing you it live. So this is the introduction to integration. So this is just a static JSXGraph figure, but then I want the students to interact with this applet so that they can see the effect of decreasing the width of the sums, and they can turn off which sums are being shown and so on as well. So this is just a chunk of the course materials. Around this, there's other content asking kind of questions about what they observe here. So I think that's the kind of most basic way of using interactivity, is just to embed something like this that the students can interact with and do some investigation, maybe with some prompts. I have tried to make it more of a task sometimes. So here's another example. Again, I'll show you the live version of this. So for this one, this is in the unit about sequences and series, and they've learned how to compute Maclaurin series. This is just, we're not going very deeply into the theory, but I wanted to at least hint at the convergence properties. So with the slider, they can see the different Maclaurin polynomials and how well they approximate the curve. And we have been having some discussion around this about convergence. So I just wanted to add in a little question. So what do you observe here? For which values does it seem like the approximations are converging to the function? So this is just a stack multiple choice question as well. Getting even more interactive, you can look for the student's interaction with the JSXGraph applet to be the task itself. So in this example, the students are meant to drag the points around. We saw an example like this in the previous talk. And what's going on behind the scenes is there's some JavaScript code as part of the JSXGraph that deals with kind of taking the coordinates that the student's given and secretly putting those into a stack input box that's been hidden from the student. So basically, as they're moving the things around on the picture, it's changing their answer to the stack question. And I should say this, I got this code from attending a session at the first Stack conference. So there was a whole workshop about that, and I can't really go into the ins and outs of how that code works, but I will be sharing these question examples, so you're free to look around and see how those work. Now there's another pitfall here. It was mentioned in the previous talk that you might want to switch to using the plain text editor. So if you are using the HTML-based editor in Moodle, if you look at what is done to the underlying code, it's changed the less than sign here to a sort of escaped version of it. And this means that the JavaScript code won't work anymore. So this is a little bit annoying. So it means that you either have to adopt the policy of always using the plain text editor. So if you were ever to open this question with the what you see is what you get editor and save the question, then it will be broken. So the solution that's one version that you can just always use the plain text editor. The solution I came up with, because I'm not rigorous enough to make sure that I always do that, is to just work around this in JavaScript. So there are ways it's a kind of nice programming exercise to find different ways to solve the same problem. So instead of using this notation for loops, you can use this notation for loops instead. And it avoids using less than or equal to signs. So that's an example of the kind of basic idea of that notation. And another thing I couldn't resist, because I was looking through some old code and found that I'd hacked and solved this another way. There's another way of writing an is less than function, which avoids using the less than sign. So that was actually useful when I was doing the Maclaurin series, because I did need to do a loop that built up the terms of that function. So just some further examples of doing this, using the JSXGraph interactively, and I think it's probably better if I show you these live again. As I say, you will have access to these. I'll explain that in a minute. So this is the question where the students are asked to drag the points to make the line have a given equation. What's going on behind the scenes here is that this is being passed as the list of coordinates to Stack, and it's able to check the properties of it as if they typed in, you know, the question could have been, give the coordinates of 2 points A and B which lie on this line. But this just makes it a slightly more graphical, visual way of asking that question. So this was a question about increasing and decreasing sequences. So the students had just been introduced to that concept. And I was asking them to generate various examples using formulas or using lists of terms. And this was a way to get them to do it graphically. So give an example of an increasing sequence. The points are constrained so that as I move left and right, I can't move that point left and right. It has to be with that particular x coordinate. There we go. I like getting green ticks. And finally, this set of examples. So this was in our first year Introduction to Pure Maths type course, where they'd just been learning about images and surjection and so on. So a bit like the example that we were seeing in the previous talk, these are just points that you can drag around to describe a function. But there's a series of prompts here which get increasingly restrictive and kind of harder to do. So first of all, make sure it has a certain image, then make sure it has that image and it's not one-to-one. Now make it onto and not one-to-one. And now make it injective, not surjective, and passing through certain points. So I'll leave that as an exercise for you to go away and play with. And it's also an interesting problem on the other side of how you deal with, you get back these lists of points, how can you check the properties of the student's answer? So it's not trivial, and it does require a bit of thought, but it's certainly possible. So just returning to the slides here, those are the answers there. Those are the ones that I came up with. And this is what I got from the students. So I've downloaded all the data and started trying to pick through and see if there are common mistakes that they're making. So these are all the students who got it right. For that final question, these are all the students who got it wrong. And interestingly in there's a whole lot of students who think a function can have kind of vertical jumps and so on. So it's interesting to dig into that. The students found this task harder than I thought they would. Okay, I'll leave it there. And just to say that through the EAMS site, if you go to the stack question section, there's a link to demo JSX graph, and that will take you through as a student to be able to see the questions that I showed you. Let me just show you that in action. So if you go to the stack section of the EAMS site, demo JSX graph, it will take you through to here. And that was the quiz that I was just showing you. It has all the examples from my talk, and you can download all of those as well. So the middle XML export is there for you to use those questions as you wish. Okay, thank you.
Thanks very much, George. We've got some time for questions. Colleagues are being a bit reticent about questions this morning, but we do have a question from Tim Lowe on the Moodle forum asking about accessibility of JSX graphs, in particular about keyboard interactions. So can you manipulate the graphs with keyboard only?
I have to admit that's not something I've tried doing.
Does anyone else have any of the other JSX graph developers? I mean, it's not just a question to you, George, but Alfred, are you able to answer that?
I will try to make an experiment until the afternoon session. Let's see.
Okay. So perhaps people could respond to that in the actual in the forum itself, because it's a really important issue that covers you know, it affects all of us. So we do have to get those things right. Make sure that the keyboard interactions are available as well. Difficult.
You mean
okay.
with the arrow keys?
Right, but having some kind of options for accessibility.
Mhm.
The usual frustration about the Moodle editors. Thank you for pointing that out, George. You may have saved somebody a very miserable afternoon. We have no other questions, folks, and so I think if unless people have questions they would like to ask, I think we will draw it to a close here.
I'll unmute myself right now, Chris. I've been busy doing conference stuff, but I have a question I want to ask.
Please, Christian, go ahead.
My question really is just about reusing code between questions in Stack. What's the mechanism for that? Do you have one?
So how do you mean? So if I'm solving some...
You have a lot of JavaScript that you have to write for these JSX graph things. How do you reuse code between questions?
Yeah, so it's not very systematic. It's really just copy and paste. So quite often I'll think, oh, I want to do a graph. Oh, I did one a bit like that in that other section. And I never really start with a blank JSX graph in that sense. I'll start with one that I had before and just copy paste and then make some tweaks.
Christian, that reminds me of one of the questions in the chat actually, who said, is George talking about Stack developer stuff or is he talking about question authoring stuff? And there is this constant tension, isn't there, between having the complete freedom to program in your own environment or having tools that you can reuse from question to question in libraries. I mean, that's the classic. And it's by no means clear what should be in a library, a systematic library that's supported, and what should be part of the individual question. That's
yeah.
Right.
Well, I think it feels a bit like subverting the system almost. You know, the drag and drop sort of questions that I was showing using the JavaScript behind the scenes. It does feel a bit on shaky ground that I'm doing something that kind of works, but I'm not confident that it will always work forever, because it's not kind of part of Stack. But I think we're sort of at the bleeding edge. So we're just trying things out and seeing what works and what we need and what's useful. And as we develop things, you know, I'm starting to realize there are certain patterns that are useful. That helps to actually inform what maybe should end up in Stack.
Yeah, and I'm sure Matthew and I will be receiving a pull request soon from you with a library of JSX functions that we should continue to support. That's the tension, isn't it? Okay, Matty is asking, did you use the binding functions for the inputs or did you create your own?
So is this a reference to, I think I saw in the docs when I was looking the other day, that there is a feature there. And so I think the answer to that is no. Okay. So I was using the code that was shown at the previous Stack conference, which I think essentially does it all within the question.
Right, so this is the classic problem, isn't it? Once we start to support those things, the back compatibility with questions you've been writing for years. So this binding stuff, as Matthew said, less magic if you use the binding functions. Right, so this is something that we need to start supporting, isn't it? When we come to these common use cases, binding things within a JSX graph picture to things within the question, and actually saying this is bound rather than just magically trying to stuff values from a graph into form fields in some web page. That's the kind of thing you're worried about?
Yeah, so that's, right. You need to, as the question author in that case, you know, so I was essentially just copying and pasting this code that someone else had provided. But it does need to worry about issues like when you reload the page, returning the points to where they were before, or when you're looking at the feedback, making sure that the question reflects what the student had actually answered.
Right, and also a common, I noticed on your question that said the answer is, and that doesn't look great when it's an internal hidden variable, right? So again, by supporting these use cases, we can make sure it actually behaves in a thoroughly sensible way in the long term. Tim Lowe's asking, are there examples of the binding functions? Matty, if you've got the docs handy, if you could post a link in there, that there should be a sample in the docs. There should be a sample in the docs. That seems like a very good place to end today. Tim, if you post that question in the Moodle, I've been looking at the chat. I've not been not been obeying my own rules here, but there are no more questions in the forum. Tim, if you Tim Lowe, if you post that question in the forum, we'll dig that out and get some examples in the doc in the forum and take it from there. George, thank you. Thank you, Alfred, for your talk as well this morning. I'm sorry about the technical problems. We'll pick that up and make sure that we follow that up with you. And look forward to seeing everyone back at the next session. Thank you very much.